determines the PSI of the concrete?
What we call a water-cement ratio. Yeah, that's a ratio of how many pounds of water to how many pounds of cement's in the mix. The lower the water-cement ratio, or the less water, or the more cement, the stronger it's going to be.
And what's our concrete rated at for PSI?
2,500 is what you're getting, and that's what the International Building Code calls for. So,
is Keystone doing anything different with the concrete that most builders aren't?
No, pretty much Keystone's doing about the same as everybody else.
The way the concrete used to be done, say 20 years ago versus what we're doing now, any differences?
Now we're using more recycled products. We used fly ash 20 years ago, 30, 40 years ago. We probably weren't using much of it. We're also using a lot more admixtures in it nowadays than we used to, and that just helps because the more admixtures we can run, the less water we have to put in, so the more durable the concrete is. Fly ash is the waste product that they get when they burn coal at coal-fired power plants. So it flies up the stack and it gets collected because they don't want to put it in the atmosphere. So instead of burying it, digging pits and burying it in the ground, we actually use it in concrete. And it's finer than cement, so it makes the concrete more durable, more dense. You also have, in your product is fly ash. In other products, we have slag, which is blast furnace slag. It's a waste product from when they melt iron ore to make steel. You also have silica fume. That's the waste product from melting iron ore in an electric arc furnace process. And all three of those are basically waste products, but we can use them in concrete to make the concrete a more better, durable concrete.
What are the differences between different types of cracks in concrete? You got your deflection, separation.
The most common you're going to see is a dry and shrinkage crack, and that's when it dries and shrinks and it cracks. You can see cracks out in the pavement. Those are dry and shrinkage cracks. We could have prevented them by putting joints in there. We just chose not to in this application. You have plastic shrinkage cracks. Plastic shrinkage cracks are generally, anywhere from a half to an inch, inch and a half deep typically. They're parallel to each other, and they occur when the surface of the concrete dries out faster than underneath. So when you get a lot of changes in weather, spring to summer, you'll see it a lot, high winds, low humidity, high sun, the surface will dry out faster. You have crazing. Crazing is, you can't see it, but if you ever see a concrete that's wet and looks like a spider web, that's crazing. It's very, very minute cracks on the surface, and there's nothing, nothing wrong with those type of cracks. Plastic shrinkage cracks as well that we talked about, that's not a structural crack. Dry and shrinkage crack is not a structural crack. Then you have a settlement crack. That's when the ground settles up underneath the concrete settles, and you usually can tell that because there'll be a difference in elevation of the concrete from one side of the crack to the other. Most cases that could be a structural crack, especially if it occurs in a house, a garage slab, or something like that.
Are there any other indicators of a structural crack?
It's basically on a house, you can look at mortar joints in the brick. You can look at cracks inside your house in the walls and the ceiling. If they start coming, you'll see you'll get some settlement in all houses eventually. When you get it too soon and too much, then that's when you have to worry about an issue.